Hello and welcome to another Common Core Algebra 1 lesson by eMathInstruction. My name is Kirk Weiler, and today we're going to be doing Unit 1, Lesson number 5 on equivalent expressions. Before we get into that, let me remind you that the worksheet for this lesson, along with a homework set, can be found by clicking on the video's description below it. As well, don't forget that on the top of every worksheet we've got a QR code. That's going to allow you to use a smartphone or a tablet to scan that QR code and come right to this video. Let's get into it though. It's important to understand terminology, right? We already know what an expression is. An expression is a combination of numbers we know with possibly numbers that we don't know. Two expressions though will be known as equivalent if they have the same value for every value of the substitution variable or variables. In other words, no matter what we stick in for the variable, x or y or z, no matter what numbers we put in, the two expressions have exactly the same value. All right, really important. Equivalent expressions have the same values no matter what you put in for x, y, or z. So we're going to play around with this for the entire lesson. It's an amazingly important idea in algebra. All right, let's take a look at exercise 1. It says, consider the three expressions below. All right, and by the three expressions, what I mean is this one, 5 times x minus 3, 5 times x, then minus 3, and 5 times x minus 15. It says, by substituting the values of x given, determine which of the two expressions are equivalent. Show your calculations of the expression's values and circle your final answers. So let's take a look. All right, in other words, what we're going to do is we're going to take 7, and we're going to put it in here for x, put it in here for x, put it in here for x, and we're going to figure out what their values are. So let's do it. All right. Now remember, in this calculation, what's going to happen first is the subtraction. So we're going to have 7 minus 3, which is 4. And we're going to do 5 times 4, and we're going to get 20. So this expression is equal to 20 when x is equal to 7. Let's try this one. Here, we have to do 5 times 7 first. Remember your order of operations, right? That's going to give me 35 minus 3, which is 32. Now, right away, by the way, this tells us that these two expressions are not equivalent. Equivalent expressions will have the same value no matter what you put in for x, y, z, v, m. It doesn't matter. All right? Let's try this last one. This last one says that we're going to do 5 times 7, and then we're going to subtract 15. So 5 times 7 is 35, minus 15 gives me 20. Hey, that one's the same. Maybe I'll put it in a square or rectangular, whatever that is. So this gives us evidence that this expression and this expression are equivalent, but they may not be. That's just one value of x. Let's try some other ones. Let's do 5 times 0 minus 3. I'm going to speed this up a little bit. So 0 minus 3, watch out, that's going to be negative 3. Then a positive times a negative is a negative, so we get negative 15. If I substitute 0 into this expression, 5 times 0 minus 3, I first have to do 5 times 0, which is 0. Then subtract off 3, and that gives me negative 3. Again, evidence that these two expressions are not equivalent. But let's see if it keeps working out that the first and the third are. Here I'm going to do 5 times 0, then I'm going to subtract 15. That's going to be 0 minus 15, and that's going to be negative 15. Ah, it is the same. More evidence that these two are equivalent. All right. We can't prove equivalency by just substituting in values, but we can sure get a good idea of it. Let's put 1 in. Remember, do as many of these as you can without your calculator, even tricky ones that involve negative numbers, like 1 minus 3 is negative 2. 5 times negative 2 is negative 10. All right, here we'll do 5 times 1 minus 3. That's going to give me 5 minus 3. That's going to give me 2. Again, not the same. Finally, 5 times 1 minus 15 gives me 5 minus 15, and that is negative 10. All right, so what we see in this table is that at least for these three x values, the first expression and the third expression give exactly the same values for those inputs, giving us a really good sense that the first and the third expressions are equivalent. But exercise 2 asks us, well, which property, the commutative, associative, or distributive, justifies the equivalency of these two expressions that you determined to be equivalent above? So think about that. Which of those things can justify that those two expressions are the same? Well, hopefully you said the distributive property. All right, because the distributive property says that if we've got 5 times the quantity x minus 3, that will be the same as 5 times x minus 5 times 3, right? So we distribute that multiplication. Sometimes teachers will show that with like little arrows like this. I know I will over the span of this course. 5 times x, not much I can do with that, just 5x. And then 5 times 3, 15. So in fact, 5 times x minus 3 and 5x minus 15 are the same, and that's justified by the distributive property. So, what is the moral of the story? The moral of the story in this problem, and pretty much all the problems that we're going to be doing today, is that we can use these three properties, commutative, associative, and distributive, to rewrite expressions in equivalent forms, okay? They'll look different. And that's one of the keys in algebra, is that often two expressions will look very different and yet will have exactly the same values no matter what you put in for x or t or y or z. It won't matter. And if it doesn't matter, then the two expressions are called equivalent. All right, I'm going to clear the text out, so pause the video now if you need to. All right, here we go. And they're gone. Moving on. Nice little multiple choice question. Which of the following expressions is equivalent to blah, right? Which of the following is equivalent to this? Right? It says, show your work to justify your response and then test at least one value of x to check your answer. So here's what I'd like you to do. I'd like you to pause the video and see if you can use things like the distributive property, the commutative property, the associative property to simplify or to rewrite this expression as one of those four choices. All right, pause the video now and see what you can do. All right, let's go through it. Well, there's not much we can do with the commutative and associative properties, not yet. But what we could certainly do is distribute the multiplication. In other words, when I multiply 2x plus 1 by 5, I can multiply the 2x by 5, and I can multiply the 1 by 5. Now what happens to the subtraction by 4? Well, it just kind of hangs out. Now, of course, here I can use the associative property. We talked about this in another lesson. I can use the associative property to actually multiply the 5 and the 2 first. Here, I'm just going to do 5 times 1 and get 5. And now, of course, I can get 10x plus 5 minus 4. I can also use the associative property of addition and subtraction to group those two together and say, well, 5 minus 4, that's just going to be 1. So it appears that 10x plus 1 is my equivalent expression. Now, how can we test this? This is kind of cool. Where should I put the test? Who knows? Anyway, let's put it up here. Now, I want to grab an x value. What x value should I grab? I don't know. Let's grab x equals 3. Grab something that you feel confident to work with. And what I'm going to do is I'm going to test the two expressions. Let me put a little line here to separate it. Let me test 5 times 2x plus 1 minus 4. Let's see what this expression is equal to. Ooh, this is a doozy, isn't it? Because we have to put 2 times 3. I'm going to use the dot instead of the parentheses, otherwise I'll have a lot of parentheses. So 2 times 3 is 6, plus 1. This is where a calculator actually might be quite helpful. Right? Just order of operations. 35 minus 4 gives me 31. Now let's test 10x plus 1. Right? So 10 times 3 is 30. 30 plus 1 is 31. Look at those two. They're the same. So that is an excellent check. In fact, some would argue it's one of the ways that you could do the problem. You could take a value of x, you could substitute it into the original expression, and then substitute it into the 4 choices. Any of the 4 choices that don't come out to be the same are clearly not equivalent. Now, on the other hand, you could get 2 expressions to come out the same and not be equivalent for a value of x. They just might have the same value for that particular value of x, so watch out a little bit. I would still suggest using properties like distributive, associative, commutative to simplify or to rewrite the expression and then test a value. All right, I'm going to clear out the text, so write down anything you need to. All right, here we go. Let's move on to the next page. Ooh, little bit worse, but the same type of problem, right? Which of the following expressions is equivalent to, again, I'm not going to read it all off, we'll just work on it a little bit. Again, show your work by thinking carefully about order of operations and the properties we've learned about. Finally, check your answer by substituting a value of x. Show this check. Pause the video. Take as much time as you need. Really think about order of operations, think about the distributive, associative, commutative properties, and see if you can figure out which of those 4 choices is the same as the one sitting up there above. Okay? All right, let's go through it. Very often, the first property that people will choose to use is the distributive property. If you see a multiplication by a sum or a difference, then it's good to distribute. So I'm going to do 4 times 3x plus 4 times 1, and that minus 2 is just hanging on, all divided by 2, and then we can't forget the subtraction by 5. I'm going to speed this up a little bit. 4 times 3x. I hope you're comfortable now that I can do the 4 times 3 and get 12x. 4 times 1 is 4, minus 2, divided by 2, minus 5. I'm now going to do the associative property here and group those 2 together. So I'm going to get 12x plus 2 divided by 2 minus 5. Now I'm going to distribute division. Now we have to be very careful about that. It would be very easy to divide the 12x by 2, but not the 2 divided by 2. So I'm distributing the division, the distributive property of division. Not for the 5. The 5's not being divided. Here I'll do 12 divided by 2, and I'll get 6x. Here I'll get 2 divided by 2, which is 1, and minus 5. And again, I'm going to group these 2 together, associative property, and I'm going to get 6x minus 4. There we go. Let's do a little test. We'll put the test over here right now. Kind of cordon off. Now again, picking a value of x, that's almost like an art. I won't go with negatives because I don't want to confuse people too much, but one thing that's a nice check sometimes is just a nice simple one like x equals 1. So let's put that into the more complicated expression. Let's see, we have 4 times 3 times 1 plus 1 minus 2, all divided by 2 minus 5. We'll put the other expression over here, but let's clean this up a little bit. 3 times 1 is 3, plus 1 minus 2, all divided by 2 minus 5. Wow, a lot of calculations here. The more you do these in your head, the better you'll become at math. 4 times 4 is 16, minus 2, divided by 2 minus 5. I'm running out of room. 14 divided by 2 minus 5. 7 minus 5 gives me 2. Oh my. Okay, let's try it in this one, much shorter. 6 times 1 minus 4. So now we're just testing this one. That's 6 minus 4, and that gives me 2. Yay! Yay! All right, wow. And again, what's critical here is that 6x minus 4 and that 4 times 3x plus 1 minus 2 divided by 2 minus 5, they're the same thing. Isn't that remarkable? They're the same. It wouldn't matter what value of x we chose. We chose x equals 1 to test it, but we could have chosen any value of x and they would have given us exactly the same output. All right. So I'm going to clean this up, pause the video. All right, here we go. Let's keep going. Okay, now, this is interesting. Exercise 5. Which of the following expressions is equivalent to 10x plus 15? Explain how you made your choice in the space provided. All right, so this one's a little bit different, but I think that you all have the ability to do it. It definitely has something to do with the distributive property. So pause the video now and see if you can figure out which one of these is the same as 10x plus 15. All right, let's go through it. Well, probably the most straightforward way of doing it is to actually apply the distributive property to each of these four. I'm going to do it very quickly. If I applied the distributive property in number 1, I'd get 16x plus 26. Well, those aren't the same, so no. If I distributed the 5 here, I'd get 5 times 5, which is 25x plus 15. Closer, but still not the same. No. If I distribute the 5 here, I'll get 5 times 2x, which is 10x. 5 times 3 is 15. Ah, yes. So there's my choice. If you'd like, I could do 4, but all I would get is 10x plus 50, which is, again, a big fat no. All right, so just choice 2. We could test with values of x, but the plain fact is here what we're doing is we're, if you will, kind of reversing the distributive property. And trust me, we're not really reversing it, we're just using the distributive property. All right, and what we're doing is we're getting our first look at what's known as factoring. All right, factoring is amazingly important. So we're going to talk about it a little more in a second. Let me clear out the text first, though. Okay. Here it goes. All right, factoring expressions. You are going to factor so much this year. Yay. Factoring is the process of writing an equivalent expression as purely the product of other expressions. So for instance, if I told you to factor 18 and you said, oh, well, that's 2 times 9, you'd be correct. You just factored it. You didn't do what was called complete factoring or complete prime factorization, but you factored it because 18 and 2 times 9 are equivalent. 18 and 2 times 9 are equivalent. In the last problem, 10x plus 15 was factored as 5 times 2x plus 3. So these two expressions are equivalent, okay? But this one is written as a product, the product of 5 and 2x plus 3, okay? So factoring is amazingly important. It's a process that we're going to practice a lot over the span of the year. It has many different uses. We'll just get a taste for it today. So let's do some easy ones. I'm going to clear this out. And let's do one final problem. All right. Factor each of the following expressions by writing an equivalent expression that is in the form of a product. Check your work by using the distributive property. All right. So here's how we do this. All right. We look at 6x plus 21. And what we want to do is we want to kind of write it like this. A times b plus c, right? Now sometimes the thing out here is a number. Sometimes it's a variable. In this case, it's going to be a number. All right? Now this is a little bit tricky because we want to undo some multiplication that we don't really know about. So here's what I'm going to do. Take a look at the 6. Take a look at the 21 and find the largest number that divides both of them. And that happens to be 3. So that's going to be my A. All right. Then the question is, well, what would I have to multiply 3 by to get 6x? Well, I'd have to multiply by 2 to get the 6 and x to get the x. Plus, now what do I have to multiply 3 by to get 21? That's going to be 7. So that is an equivalent expression that's been factored. We can check it by simply multiplying back through to see if we get that. And we do. So take a look at letter B. right? Take a look at the 2. Don't worry about the negative and the 10. What number divides both of them? What number goes into both? And that would be 2. Or negative 2, whichever one. Maybe we'll do it with both. If I write it as a 2, then the question is, well, what would I have to multiply 2 by to get negative 2x? And I'd have to have a negative 1x. The 1's actually not mandatory. And then I'd have to multiply it by 5 to get the 10. On the other hand, if I had factored out a negative 2, then I would just simply have to multiply it by x to get negative 2x. This is the tricky part. And then I'd have to multiply it by negative 5 to get positive 10. Either one of these would be completely okay. All right, let's look at letter C. 14 and 14. Ooh, well, I know what divides them both. 14. So if I pull the 14 out, well, then I'd have to multiply it by x to get 14x. And then I'd have to multiply it by 1 to get 14. So 14 times x plus 1. All right, so that's how we factor. Well, that's one way that we factor. There's going to be many different types of factoring, but ultimately, at the end of the day, all factoring is reversing the distributive property. Every time it's reversing the distributive property, and writing an expression as something that's equivalent in the form of a product. Okay? So pause the video now, and I'm going to scrub out the text. All right, here we go. All right, let's finish up. The idea of equivalent expressions could be one of the most important in all of algebra, because every time we manipulate one side of an equation or another, we're manipulating an expression. And we're always manipulating it to get an equivalent expression. All right? Once we lose equivalency, then we really change a problem. It's just changed entirely. So it's very important to understand that we use these laws of numbers and operations, specifically the commutative property of addition and multiplication, the associative properties of addition and multiplication, and the distributive property, to rearrange algebraic expressions to get ones that are exactly the same but might look different. All right? So, I want to thank you for joining me for another Common Core Algebra 1 lesson by eMathInstruction. My name's Kirk Weiler. And until next time, keep thinking and keep solving problems.